All right, so let's consider this part B. We are given two curves. I labeled them as like R1 and R2 just for our reference. One is 5 minus 3 sine theta, and the other one is 5 minus 3 cosine theta. And we're interested in finding the common interior as a region first, and we're going to find the area of the common interior next. But before we start, please have your TI-84 ready, and please plot R1 and R2 in the same plot, and please go from theta equals 0 to theta equals 2 pi to see the full picture. And our first task is visually pinpointing the intersecting points, okay, and find visually where they are. And in the next step, we're going to find them analytically exactly. And once we determine the interior, once we determine the intersecting points, then we're going to see how we can sweep the mentioned area of or area of the region, and that involves choosing the theta values for the integration for the lower limit and upper limit. So that requires some analysis. So, but the first thing is first, please graph these two curves, and you can pause the video anytime, but I'll show you what I got at my end. Okay, so R1 is the blue graph, so this is R1, and purple is R2. Okay, if you can't really distinguish the colors, so I'm just like writing on the graph so you can see which one is R1 and which one is R2. Okay. And they do intersect, these two curves do intersect at two instances. And it does look like that theta values for those are pi over 4 and 3 pi over 4, but we have to find that out. And that's why you should have the table with you as well. Okay, and in the past, remember, I used to make my own table by handwriting. And I was trying to walk you through that. But this time we have two curves, and I don't want to spend too much time for it. That's why I put the table right away for your own reference, so that you can pause the video anytime and check those numbers. But I can perfectly see that at pi over 4 and 5 pi over 4, r's are exactly the same. So we know those intersecting points, but let's try to find them analytically first, okay? And now what we're going to do is to set R1 and R2 equal and solve, okay? And as you see, like in these kinds of problems, we are always solving a trig equation, and it's always better to have the unit circle with you because at the end of the day, sometimes you get known angles to work with, and unit circle immensely helps, okay? So what I'm going to do here is subtracting 5 from both sides. Okay, and then divide both sides by -3. How about that? So sine theta equals cosine theta. All right. So you can go ahead and divide both sides by cosine, so that you get tan theta equals 1. But using the unit circle towards checking tan theta equals 1 is not that easy. But instead, this equation is helpful to use the unit circle. And at this level, by the way, you can still use like tangent theta equals 1 level. You can still use your calculator to find arctan 1. But again, it's going to spit out only one value. You need two values. So you need to approach it in a specific way. And once you get one point, then you can actually get the other point by using the symmetry property on the unit circle. But at this moment, sine theta equals cosine theta is good enough for us to go back to the unit circle. All right, here is the unit circle. We're looking for sine and cosine to be equal. That means I'm looking for points where the x and y coordinates are exactly identical, okay? So that means because x entry is a cosine of that angle and y entry is the sine of that angle. And when both are equal, that means we're looking for these two guys here. I can pinpoint these guys where x and y entries are exactly the same. And for all others, as you see, x and y values are different. And these correspond to pi over 4 and 5 pi over 4. Okay, so let's go back. Let's go back and write down the solution of this problem as theta equals pi over 4 and 5 pi over 4. And I also observed this from the graph. Remember that we got pi over 4 and 5 pi over 4 here, and these were the rays where the curves intersect each other. Okay. All right. So now the question is like, what is the common interior of these curves? Well, I can see that here, right? So we're talking about this full region. Okay. And we're talking about the area of that region. But let's see what it consists of first, okay? What it consists of. Well, we can split that region into two parts. And if I can find the area of this one, so let me just maybe use highlighter here. If I find the area of this portion and multiply it by 2, you're all done. Or you can instead, you can just find the area of this portion here. Let me just shade this area here, right? And multiplying by 2 would just give you the full area of the common interior. So now the question is like, how am I going to find either one of those, either one of those areas? Okay, so that's the question. Please think about it, and which curve, in fact, I'm going to use to sort of like cover or to sweep one of those regions. All right, let's see where we start here, because if I know what this point corresponds to for, let's see, blue is R1, right? For R1, and if I know what this point corresponds in terms of theta, which in fact you can visually see, but I want to see the orientation as well, so that I can move theta from the first one to the last one, so that sweep that area. So I want to move on this curve starting from here, going all the way to this point, okay, on the ray 5 pi over 4. Okay, so let's check. For theta equals 0, R1 starts at 5 and R2 is 2. All right, so the blue curve is going to start right here because R1 equals 5. And R2 equals 2 means this curve is going to start right here. Okay? And at pi over 4, it's 5 minus 3 radical, 3 over radical 2 for both, and they meet right here. And this curve moves like this. Okay? And now what I want to do is to check what happens at pi, because pi is in between. So at pi, R1 equals 5. Here we go. I'm going to walk 5 units to come up here, and then yes, okay, that's good. So and at 5 pi over 4, we have the value of r to be equal to 5 plus 3 over radical 2. Okay, so what I'm going to do is to move R1 from pi over 4 to 5 pi over 4, and use the area formula for that, and that's going to give us this area. So the area formula is going to take us to this area, and I'm going to multiply it by 2 to get the total interior, the area of the total interior. All right, so let's see what we can do for it. There we go. Total area of the common interior, okay, is going to be, first of all, 2 times 1/2. You're going to go from, let's just go back again, pi over 4 to 5 pi over 4, and we're working with R1. R1 squared, so 5 minus 3 sine theta squared d theta. Okay? And the reason why I multiplied by 2 is because I have another portion of the graph, another portion of the common interior right here, that region, right? And this is identical to what I'm calculating, so that's why I multiplied by 2. Okay? So simplifying this, so you have pi over 4, 5 pi over 4, and let's expand this out. 25 and minus 30 sine theta, and I think plus 9 sine squared theta. And we still have sine squared theta here, so I'm going to use the power reducing formula for it. Okay, so I'm just erase this and replace that by 1 minus cosine 2 theta over 2 d theta. Okay. All right, let's find the antiderivative in one shot. Okay, so here we go. I have 25 theta minus plus 30 cosine theta plus 9 theta over 2 and minus 9 over 4 sine 2 theta. And this is from pi over 4 to 5 pi over 4. Okay. All right. So I'm going to write this calculation here. So I'm going to plug in the upper limit. So 25 times 5 pi over 4, which is 125 pi over 4 plus 30 cosine 5 pi over 4 plus 9 times 5, 45 pi over 8. Okay. Minus 9 over 4 sine 5 pi over 2. Okay. And I'm going to subtract pi over 4 plugged in. Okay. Why don't we continue from right here? All right, so I moved everything in the bottom to the top, and I'm going to subtract pi over 4 plugged in right here. So 25 pi over 4 plus 30 cosine pi over 4 plus 9 pi over 8 minus 9 over 4 sine pi over 2. Okay. All right, I'm going to skip the exact calculation here from my end because this video is too long already. I'm going to just write down the result here. So it's 59 pi over 2 and minus 30 root 2. And this is approximately equal to 50.251. Okay, please do this calculation by yourself. And I intentionally skipped that because, again, this video is too long. And take your time and convince yourself that this area is equal to 50.251. Okay. And this is in fact the area of the interior, total area of the interior here, which is in fact, let me just highlight this. So we're talking about this region here. Okay. All right. So thanks for watching this video, and please have the table ready whenever you have a problem of this sort. And I'll try to see you in another video. Bye.